Hello, welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. So, we have been talking about the derivation of the Jacobian matrix elements. So, we have so far covered first two rows. So, let us now try to recapitulate. So, what we had is that our Jacobian structure is something like this: del P, del Q, del P gen, del V specified. So, this is our Jacobian matrix. So, this is our mismatch vector, and then we have J1, J2, J3, J4, J5, J6, J7, J8, J9, 10, 12, 13, 14, 16, and then we have delta theta, delta V, delta theta internal, del V internal. So, this is what is our Jacobian matrix structure. Of course, all these are so then therefore, now all these J1, J2, J3 up to J16, these are nothing but the Jacobian submatrices. So far we have looked into detail the derivation of the elements of the matrices J1 to J8. So, now today we will start looking into the matrices J9, J10, J11 and J12. So, then therefore, J9 would be from this del P gen. Of course, this is a vector, all these are vector, all these are vector, all these are vector, del P gen by del theta, J10, J10 would be del P gen by del V, J11 would be del P gen by theta internal, and J12 is del P gen by del V internal. Of course, now we have already looked into the vectors theta, V, theta int and V int. So, then we are not going to repeat it. What is the vector P gen? P gen vector is P gen gen 1, P gen 2 dot 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 P gen M transpose. So, what is P gen I? P gen I is the real power generation. I am wrong here. It would be not P gen. This would be P gen 2, P gen 3. P gen I is real power generation. I should say total real power generation of generator I. Generator I means is actually in our parlance that the generator connected at bus I. Please note that in our case we have assumed that all the M generators, they are connected at the first M buses of the system. So, generator connected connected at bus I. And so then therefore this vector is m minus 1 cross 1. That is obvious because there are m minus 1. Why this pgen 1 is not there? Because we said that there would be one generator which would be acting as a slack bus. So then therefore for that particular slack bus we really cannot pre-specify the total real power generation until unless we solve the load flow program. So now we have to, so then therefore, so now if we have to take, so then therefore J9 would be basically, and we said that, so then therefore J9, for example, J9 would be looking like this, del P gen 2 by del theta 1 b, then del P gen 2 by del theta 1 c dot 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 del P gen 2 by del theta n c, right. Then the second row would be del P gen 3 by del theta 1 b, then del P gen 3 by del theta 1 c dot 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 del P gen 3 by del theta n c. So all this we will go, and then last row would be del P gen m by del theta 1 b, then del P dot 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 gen m by del theta 1 c dot 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 del P gen m by del theta n c. The reason for this, that we again recollect that this theta vector is essentially theta 1 b, theta 1 c, then theta 2 a, then dot 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 theta n b, theta n c transpose, right. And we again note that the generation 1 theta 1 a is equal to 0, so it is the reference angle, and generator 1 is the slack bus. Generator 1 is the slack generator. So then obviously, so now to derive these elements, we have to now essentially write down the expression of P gen I. So now let us look at what would be the expression of P gen I. Now let us recollect one simple fact. Now let us take an example to understand. To again, let's say n is equal to 5, m is equal to 3. Let us just, so let's say that this is the structure, this is the structure. So this is, these are important. So this, so let's say that this is bus 1, this is bus 2, this is bus 3, this is bus 4, this is bus 5, and at bus 1 there is one generator, and bus 2 there is another generator, and at bus 3 there is another generator. So n is equal to 5, that is there are total 5 buses in the system, and there are 3 generators. And we know that this system is being augmented by, so it is being augmented by internal buses. So these are the original buses, and now I have got internal bus. So here also I have got internal bus, and my generator is actually connected here. And now I also have an internal bus, and these are the original lines. So these are right. So the bus number is 1, then this is 4, then this is 2, then this is 5, then this is 3, and then we said that this would be 6, this would be 7, this would be 8. That was the kind of convention for naming the, or rather for actually numbering the internal buses we have adopted. So that means the internal bus number would be I plus n, right. So internal bus number is, so internal bus corresponding to ith generator is n plus I, right. So this is the convention we have followed. Now here in this case, now here we are actually talking about, now for this system my pgen vector is pgen. My pgen vector is actually pgen 2 and pgen 3. That is my pgen vector. Okay. Now you also said that when we are actually creating the internal bus for our convenience, we are also shifting the position of the generator from the original bus to the internal bus. So my generators are now connected here as if. This creates no problem as far as the real power is concerned, because we have assumed that this one is the essentially this is purely reactive. So then therefore there is no real power loss. So then therefore whatever real power is being injected here, this entire real power is also arriving at bus 1, right, which is also the case in the original case. So then therefore P gen 2 is nothing but is equal to P7. So then therefore in our case I can say that by looking at this, P gen 2 is nothing but is equal to P7, and P gen 3. Now please note that this total P gen 2 is nothing but the total 3 phase power generated by this generator. Now the total 3 phase power generated by this generator would be, that would be is equal to power generated at phase A, that is P7A, plus P7B plus P7C. What is P7A? P7A is the real power injected by this generator at bus 7 corresponding to phase A, right. Similarly, P7B is real power injected at generator at bus 7 corresponding to phase B, and this is at corresponding to phase C, right. So, let us write that P IP, it is our usual notation we are actually following. Similarly, P gen 3 would be here P8A plus P8B plus P8C, right. So, it would be P8A plus P8B plus P8C, because you see total real power generated by any generator is nothing but the sum total of the real power generated at phase A plus phase B plus phase C. Now, because we have shifted this generator at bus 2 to bus 7, so then therefore, total real power generated by the generator at bus 2 would be equal to the total real power generated by the generator located at bus 7, and total real power generated by the generator located at bus 7 would be equal to the real power generated at bus at phase A plus real power generated at phase B plus real power generated at phase C. Similarly, for the generator connected at bus 3, correct. So, then therefore, in general we can say in general I can say in general. Now, here you can see that P gen I is equal to P8. Now, so then therefore, when I is equal to 3, it is 8. 8 is nothing but 5 plus 3, and basically what is 5? 5 is nothing but n. So, then therefore, P gen I that would be is equal to Pn plus Ia plus Pn plus Ib plus Pn plus Ic, correct. For and the and I is M2. What is Pn plus Ia? It is basically Pn plus Ip is essentially it is nothing but, so just let us write down Pn plus Ip is that real power injected at bus n plus I at phase P. P is A, B, C. Now, what is Pn plus Ia? Now, what is Pn plus Ia? Now, Pn plus Ia is, now I know that PIP we have already said that it is L is equal to A, B, C, and then we said that J is equal to 1 to N plus M. Then we said that V, I, P, V, J, L. Then we have Y, I, J, P, L. Then we have cosine theta I, P minus theta J, L minus alpha I, J, P, L, right. So, this is the general expression. So, then therefore, from here I can write down that Pn plus Ia would be is equal to L is equal to A, B, C, J is equal to 1 to N plus M, Vi. So V N plus I A because I is equal to N plus I and P is equal to A. Then usual V J L Y. I in place of I it is N plus I, then J, then A, then L, cosine theta N plus I A minus theta J L minus alpha N plus I J A L, right? So this would be the case. So it appears that P n plus I A, so then therefore similarly P n plus I B, similarly the expressions for P n plus I B. Now let us look at one very interesting thing. Suppose as an example, suppose we are trying to write down example n is equal to 5, m is equal to 3, and we are trying to write down say P7A, right? So if it is P7A, so in this case what will happen? L is equal to A, B, C, J is equal to 1 to N plus M is 8, then V7A, VJL, then Y7JAL cosine theta 7A minus theta JL minus alpha 7JAL. So this would be the case. Now let us look at a very interesting thing. Bus 7 is basically directly only connected to bus 2. Bus 7 is not directly connected to any other bus. So then therefore in the Y bus matrix the quantities Y73, Y71, Y76, Y75, Y74 as well as Y78, they will be all 0. Only the elements of the bus admittance matrix corresponding to bus 7 and 2, they will only exist, right? So then therefore Y71 ABC would be 0, Y76 ABC would be 0, Y78 ABC would be 0, Y73 ABC would be 0, Y74 ABC would be 0 only, and also Y75 ABC would be 0. Only Y72 ABC would be non-zero, Y77 ABC would be non-zero, and Y22 ABC would be non-zero. Other than these three, they will not exist because they will all go up to 0. So then therefore for this, what it will, so then therefore this j is equal to 1 to 8. So for 7 1 it would be 0, when it is 7 2 it would be there, when j is equal to 3 it is 0, right? When j is equal to 4 it would be 0, when actually j is equal to 5 it would be 0, when j is equal to 6 is it will be 0, and when j is equal to 7 it would be non-zero, right? So it will be only be there for only j is equal to 2 and 7. Other than that, that all the others they will not exist. So then therefore this can be simplified as AL is equal to A, B, C. J will now only have two values, 2 and 7. Then V7A, VJL, y7j al, then cosine theta 7a minus theta jl minus alpha 7j al. Right, so now it has now become considerably simplified. So how many terms would be there? There would be only 6 terms. I mean, basically this one is a single term. So when I am talking about term, so we are saying that these are one term. So these are one term, one single term, right? So there will be essentially only 6 terms. All the other terms, now here in this expression, there would have been 3 into 8, that is basically, actually theoretically there would be 24 terms, but here, because this is an internal bus, these 24 terms, out of these 24 terms, 18 terms will be all 0, only 6 terms will essentially remain, right? Similarly, I can say that P7b will also be equal to L is equal to A, B, C, and then here also J is equal to 2 and 7, and then it will be V7b, then VJL, Y7JBL cosine theta 7b minus theta JL minus alpha 7JBL. Right? In the same way, P7C would be similarly P7C would be L is equal to A, B, C, J would be 2, 7, then it would be V7C, VJL, Y7 JCL cosine theta 7C minus theta JL minus alpha 7 JCL, right? Alpha 7 JCL. So then therefore P gen 2, so then therefore P gen 2 is equal to P7A plus P7B plus P7C, right? So if I now look at them very carefully, so then it would be essentially L is equal to A, B, C, J is equal to 2, 7, then V7A, VJL, Y7JL cosine theta 7A minus theta JL minus alpha 7JAL plus V7B, VJL, Y7JBL then cosine theta 7b minus theta jl minus alpha 7jbl plus v7c vjl y7jcl cosine theta 7c minus theta jl minus alpha 7jcl. So that is the p gen 2, right? So we stop here with this and then we will continue in the next lecture. Thank you.